Hello, my name is Professor Glenn Patrick. I'm a particle physicist and spent much of my career working at the CERN laboratory in Geneva, including on the Large Hadron Collider. I'm also a science communicator and spend some of my time writing articles, talking to audiences, including on cruise ships. I'm an honorary research scientist at the Rutherford Appleton Laboratory near to Oxford. I also have various academic appointments, including visiting professor at the University of Portsmouth. I'm a fellow of the Institute of Physics and a fellow of the Royal Astronomical Society. So at this point, I want to share my screen. So that's basically my background listed again there. But what I want to do is to give you a flavour of my talks. Now, I've been a cruise lecturer for about 7 years. I've worked for Cunard, Marella, Saga, and Viking Cruises. I mainly lecture on science topics, including astronomy, cosmology, and earth sciences. And these 12 talks give you a flavour of the range of topics that I can cover. So as an example, obviously I'm interested in the very small. And if we go back about 400 years, the very small would have been this, a horse tick. And people like Robert Hooke, famous English physicist, would have observed this through an optical microscope and actually had to draw what he observed, unlike today. But over time, and certainly through the 20th century, we've understood the structure of matter. And so we understand that matter is composed of molecules, and that molecules are composed of atoms. At the center of an atom is what we call the atomic nucleus, discovered by Lord Rutherford. And the atomic nucleus is composed of clusters of protons and neutrons. And surrounding the nucleus is the electron, clouds of electrons. And as time has gone on, amazingly, we found even more structure. So protons and neutrons actually are composite particles. And we can see that inside them are these strange particles that we call quarks. So a proton has got 3 quarks swirling around inside, bound together by the strong nuclear force. And that's why we don't fall apart. So is that the end of the story? Well, no, because if we go to accelerators like this, the Large Hadron Collider, we can produce other species of particle. And most famously, of course, the Higgs particle was discovered there. So by colliding intense beams of protons together at high energy, we can discover further particles. But as is often the case, nature can do much better. Why do I say that? Well, that's because of this, the aurora or northern lights, which we observe over Arctic regions. And the reason the northern lights are related to particle physics is because the sun emits streams of charged particles, the so-called solar wind, that interacts with their magnetosphere surrounding the Earth. And due to that interaction, atoms get excited in the atmosphere. So mainly nitrogen and oxygen. And when those atoms get excited, electrons jump from their orbits, emitting light, as shown by this animation in the left-hand corner. So the different colors are due to the different gases and due to the different energies emitted. Oddly enough, there are even more energetic particles out there. Some of these particles have such an intense, ultra-high energy that they exceed anything that we can produce at the Large Hadron Collider. There's been a big mystery of where they come from, and we still don't know the full story. But here's an example of one. This is Antarctica shown here. And in 2017, there's a very special detector using the ice sheet of Antarctica called IceCube that detected a particle called a neutrino, of extremely high energy neutrino. And when we tried to trace out and work out where it came from, we actually discovered it seemed to originate from an active galactic nucleus. That's just a fancy name for a very luminous galaxy. And the reason it's luminous is because it's thought that there's a black hole at the center. So what seems to happen is that this is like a vast cosmic accelerator, accelerating particles and then spitting them out towards the Earth. Another important topic, of course, these days, a very important topic, is climate change and what do we do about it? And this is a rather iconic photograph. Iconic because it shows several glaciers in Iceland and one of them has disappeared, shown here. And it's the first one to disappear due to climate change. And it's predicted that all of the glaciers in Iceland at the current rate will disappear in the next 200 years. And the reason for this is the so-called greenhouse effect. And the greenhouse effect is due to gases in the atmosphere, which absorb the solar radiation reflected from the Earth. There are some gases which are better at doing this than others. And the reason for this is because their molecules vibrate more. And a good example is carbon dioxide, CO2. And you can see that there are 3 vibration modes shown here. And this is what gives it the ability to absorb energy and to emit energy and contribute so greatly to the greenhouse effect. So I'd like to finish here with this quote from Stephen Hawking: "Look up at the stars and not down at your feet, be curious. And on a cruise, you have the time to relax and be curious." I'm just going to stop screen sharing here and come back to you briefly, just to say that my aim is to not only entertain passengers, but also to share our wonder at the natural world and the scientific world and how we can explain things on our travels. I'm always very keen to adapt my talks to the itinerary and very willing to write new talks for new cruises. Thank you for listening again.